Now let's look at the idea of with replacement. What does replacement mean? Well, you should all know that replacement is putting something back into the original spot, makes up, so it looks exactly the same as it originally was. For example, if I'm picking out a jelly bean from a jar, and I pick out a blue jelly bean, and I look at the color, and if I eat it, I can't replace it back because I've eaten it, it's gone now, so I'll have one less jelly bean in my jar. But say, for example, I picked the jelly bean, I looked at it, and then I put it back in. That means I've replaced the jar. So I've replaced that jelly bean, I've replaced that missing spot, which means I have the same number of jelly beans left in the jar. Depending on whether there is replacement or there is no replacement, the probability of an outcome changes. So you must take good consideration of that when you're doing a question. Let's try the question so you get the idea of what I mean. A box contains 4 times the number of 10 cents as 5-cent pieces. A coin is randomly withdrawn from the box and replaced. This is done 3 times. The number of 10-cent coins is 4 times a 5-cent coin. So 5 cent is 1, the 10 cents would be 4. So if I make it as a ratio, it will be 4 to 1. So this is 10 cents, this is 5 cents. So in total there are 5 parts. So if I want to find the probability of getting 3 10-cent pieces, so we know that the probability of getting a 10 cent is 4 out of 5 because there's 1 plus 4 and there's 4 that makes the 10-cent coins. So I simply have to find, well, that's what I've just said, 4 out of 5 is 10 cents and 1 out of 5 is the 5 cents, the probabilities. To get 3 10 cents, I simply multiply 4 on 5 3 times. The reason why it's 4 on 5 constantly is because it says a coin is randomly withdrawn from the box and replaced. And you multiply them together to get 64 out of 125. Now B, find the probability of getting 2 5-cent pieces and 1 10-cent piece in the 3 drawers. This can have multiple ways. So we could have 5 5 10 or 5 10 5, 10 5 5. So there's 3 outcomes we can think of. We have to consider different orders. Getting a 5 cent and a 5 cent is 1 out of 5 and 1 out of 5. The probability is the same because I'm replacing the coin back, which means I'll have the same number of coins left inside, so the probability won't change. So it's 1 on 5, 1 on 5, and then we want 10 cent, so it's 4 on 5. So that's the first outcome. And then we say OR, so we must add. Remember OR is plus, so we add it to a 5 cent, 1 over 5, 10 cent, 4 over 5, and 5 cent, 1 over 5. So that's the second outcome. Or, so we plus, and then we have 10 cent, 5 cent, 5 cents. So 4 on 5, 1 on 5, 1 on 5. And then we add all of these together. So do a bit of calculation, just be very, very careful, and you should get 12 on 125. And then C, find the probability of getting a 10-cent piece on each of the last 2 drawers, which means I want it to be 5 cent and 10 cent and 10 cent, or 10 cent and 10 cent and 10 cent. The only limit to this is that the last 2 must be 10 cents. The first one can be 5 cent or a 10 cent. That's why this event has 2 outcomes. We're going to think about both of them. So you can see that 5 cent is 1 on 5, 10 cent is 4 on 5, 10 cent is 4 on 5. So same here, the last 2 will be 4 on 5. And then because this is 10 cent, this will also be 4 on 5. So we multiply these 3 together and these 3 together, and you add them up because it's this or this. So you get 16 on 25. 16, Susan draws 3 cards in succession from a pack of 52 cards. Find the probability that they are all hearts. A card is replaced after each draw. A card is always going to be replaced, so the probability will be the same for all outcomes because we're replacing, so there will be same number of cards left. So I want to find the probability that they are all hearts, the card questions again. So you should be able to tell me how many hearts there are. We know that there are 4 shapes, so a quarter of it is hearts. The probability of getting a heart and a heart and a heart is 13 out of 52, which is 13 is exactly 1/4 of 52, so that's why we have 13. And then because we're replacing, the probabilities of the next events will be the same because there's the same number of cards left, and you should get 1 on 64.